Although C has been called a system programming language because it is useful for writing compilers and operating system, it has been equally well to write major programs in many other different domains as well. And the very new thing that I came to learn about the C programming language is C language is pretty much inspired by B language. So I was kind of astonished that B language, is there a B language as well? So search B language. Yes, B language is a programming language created by Dennis Ritchie at 19s. B was a precursor to the C programming language, which is still popular in computer science today. So today we are going to write a very simple C program and see what's really happening inside our program. For that we are going to use GDB, GNU Debugging Programmer tool. It helps us to see what's really happening inside our program. So today we are going to dive deep inside the C programming language by using GDB as well. So let's get started. So for this we are just simply going to create a let's say hello world at C, because we are so okay. So first it should be include studio. It is including the information about the standard input output library, and then I'm going to open a main function and I'm going to return 0. Okay, so I'm simply going to print hello world. So I'm going to compile it into the what you call, I'm going to just it's going to do this. So here is an executable file called hello world. So if I run this, then it will simply print the hello world, right? So we can see we're simply printing the hello world. If we do not include this file, standard IO file, then we cannot use this built-in printf function. That's why we're including this. And where we have opened the main function, our main procedure, which is calling a print function, which is going to print the hello world into our console or into our terminal, right? So what really happens when we run this program is we're going to learn more about this. So going to here, so we have a GDB. You know, it is a copyright is for bugging, so it's basically a debugging programmer, right? So we have hello world executable. So I'm going to do this is for I'm going to disassembly flavor. I'm going to use the Intel syntax for the assembly, which is favorable for me. That's why I use Intel. Okay, so I'm going to list it. So as you can see that this is my program, include stdi.h. Now I'm going to disassemble main function. I'm going to just disassemble the main function into the assembly language. Okay, so int main into it like this, I guess. So int main, so this function is equivalent to this assembly code, right? So this is what actually happens inside our program. Okay, first we're going to set a break. We are going to set break at the main function and we are going to run it. Okay. Okay, so we can see the registers as well. There are RAX, RBX, RCX, RDX, RSI, RD. It's everything, right? Okay, deleted breakpoint. I think I have to run it. Yes. is a very special register known as RIP, which points to the current instruction. So if I want to see info registers about the RIP, so RIP is, we can do this. So RIP is uh, yes. So we can see that RIP register's location is this 0x555513D, and it is storing the value this 055113D. Okay, so when I and it is at the main plus 4, that means that it is at this this line of statement, so means that it has already been executed. So move means that first we push the RBP pointer on the stack, then we uh, move the value of stack pointer to the base pointer. So now we can see that x dollar, if I see RBP, okay, so our base pointer is pointing at the 0x0001 location, and it should point at the stack pointer as well. Yes, our stack pointer is also pointing at the same location. So now the next instruction is to LE. Now the next instruction is, yes, this is our next instruction. So lee RAX. So what it is going to do is it is going to now our RAX is going to store the address of the RIP plus 0xEC0. So whatever is there at the address, it is going to not the content, just the address. LE is load effective address. It is simply going to store the address without dereferencing the memory. That's why let's see first what is there at the RIP plus 0x is, so I think no, we'll look at this x as x, so it is saying RIP plus 0xEC0. So it is the 0555555 LFT. Since this statement is not executed yet, there it stores the value 10 0 10 0 10 0. So I'm going to execute this command learax. So now it has been executed. We are going to see okay, let's this way, RIP plus 0x EC0. Oh, you can see hello world is there, and now it has been loaded into the RAX. We can see this by RAX. Let's see, string RAX, right? So the hello world has been loaded. Next I, it is loading everything, and now our I can do the shortcut RIP. You can see that it is at the line 24. So it is at the line 24 now, means that yes, so the hello world is located at this location, and then now it has been loaded the RDI, because RDI is a special register which is going to store the first argument. That is the argument. This is the argument for the yes, this is the first argument that we pass to the printf, right? So we need to store this content into the RDI, because RDI register is used for storing the arguments. So that is used to store the hello world. So now our hello world has been stored in the RAX, and from RAX to RDI, and then we have called the print function, which will print the content of the RDI into the console, and then we are removing the base pointer from the stack, and that's how our program works, right? So yes, what basically happened is, okay, let's consider this is a stack of, let's consider sorry, consider this is a stack, this is our memory, right? So I'm going to copy this code, to paste it here. So let's do this way. So I'm going to open a main function, and then I'm going to print f hello world, and then I'm returning 0, and then I'm closing this. So what happens when we call the main function is so whenever a function is called where the base pointer is, so this is a stack, right? So let's suppose um, this up. So let's suppose there is a so let's suppose there is first our stack pointer is pointing at the top of the stack, right? Let's say this is the top of the stack for now. So what happens is whenever a main function is called, the base pointer is, yes, we can see that the base pointer is so I guess the base pointer is pushed to the stack, right? And then yes, now the we can say that okay, this is the top of the stack for now. So RBP has been pushed, and then we have moved the RSP to the RBP. So now they point to the same, and then this is our stack. And then when we run our program, then let's say our hello world is stored here. I mean starting from memory address 0x for now let's just say that. So yes, so our hello world is here and our RBP is pointing to that. After RBP, our return address is pointed to the we know that key. We have our return address here, or I can keep it here. Is the return address. Then after that, what happens is okay, let's say here we have RTX, right, RX, let's say RX. So RX is here. So what now is doing is now RAX is pointing to this direction. It's two directions. So RXS is holding the value 0x A, right? And then after that we have RDI. This is destination index, I think. Yes, destination indexer or destination index. So now it is pointing to this, and which means that it is indirectly pointing to this memory, right? And then in this way, when we call printf function, and then it called the printf function, which register holds the first argument for the function. So before calling printf function, our RDI holds the hello world, and when we call the printf function, then the hello world will be printed to the system. Are you understanding what I'm saying? I'm just basically trying to say that how when we just print f the hello world, it just doesn't magically print the hello world. First, it pushes the function into the stack, then the return address, and if there are any local variables, they are also pushed into the stack, and then there are several registers. For example, RDI, which is responsible for holding the first argument. Then we have RSI, which is responsible for holding the second argument of the functions, and then the printf functions, which is the built-in library functions, which will print out into the console, right? So I think that's it for today's class. Today we learned what really happens inside our C program. We try to see what happens inside a program using the GDB, GNU Debugging Programming Tool, right? So yes, thank you.